This integration by parts integral requires applying integration by parts twice. But first of all, let me remind you that you have this method here, LIATE, which influences the choice of u and dv. So the choice of u comes from left to right. You look for a logarithmic expression, inverse trig, algebraic expression, trigonometry, and exponential function. In this case, we have trigonometry and algebraic expression. So we are going to choose our u to be an algebraic expression because it has, higher order. That is a then t. So we choose u to be x squared and take the derivative of u, that is du, which gives us 2x dx. In the same way, our dv is the remaining function. So dv is equal to cosine x dx. And when we take the integral, we have v is equal to, the integral of cosine x with respect to x, so that v is sine x. Next, we just apply the integration by parts formula. So the formula gives us uv. Our u is x squared, v is sine x, and our du is 2x, so we can take the 2 outside and write the integral of x sine x dx. So you realize that we have another integral, which is the integral of x sine x, which we have to apply the integration by parts again. In the same way, I choose u to be x, so that du is dx, then dv is sine dx, so that v is negative cos x. So if we use our formula, the first part we have x squared sine x, which comes from the first integral, then minus 2. The integral of x sine dx is negative x cos x plus, when we integrate the v, which is cos x, we get sine x, then plus c. Let us go ahead and distribute the negative 2. So don't forget that there's a negative 2 that comes from here with a negative, so the first part becomes a plus and the second plus becomes a minus. Then you add the c.